Okay, we are getting started for lesson 16, week 9, I think we're in. And we are going to go over the quiz, and then we're going to talk about our group project. So for the quiz, we just need to have the probability applet pulled up, and then we can go through the questions. Just everyone let me know when you have the quiz pulled up.
Okay, mine's pulled up.
I'm good too.
I'm almost there. First time's the last one always.
No problem. Nope, that's just fine.
I don't know why I don't pull it up beforehand.
Well, maybe we were going to talk about something in the chapter lesson 16 that you had to have pulled up.
Right.
Thank you.
You never know.
All right, I got it pulled up now.
Okay, number 3. In a pie chart, why are the slices different sizes? I say C. Each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category.
I don't know, Larky. I think B is kind of appealing.
The size of each slice is determined by the number of categories. That's partial.
No,
Yeah.
no. D. Pie charts are more visually appealing. They're prettier.
D. Oh, D. So yes, C, everyone?
Yeah.
Yeah, that
Yeah.
sounds good.
All right. Sharon, you want to do question 4?
Yeah. How are bar charts and Pareto charts related? Pareto charts are constructed from tossing a coin several times. They are identical. The only difference between a bar chart and a Pareto chart is that the bars in a Pareto chart are ordered largest to smallest, going from left to right. See?
Yep.
Yeah.
Okay, number 5. We conclude that p hat is normally distributed if NP is greater than or equal to 10 and N1 minus P greater than equal to 10. Is P the true proportion or the sample proportion? So in the book, the formula that I have is U p hat equals P, which is the population proportion. And so I say that P is the true proportion of the mean or whatever.
Okay.
And then
I'm glad this is a question because I was actually a little confused about the difference between P and P hat. So P is the perimeter, right? That's what I gather. And then P hat is a sample proportion. Is that right?
Yeah, so like when pretty much the p hat and the p equal each. If you look, it's in lesson 16. There's a little like, oh no, that was in his slides. Basically, like p hat equals p. And so, like if you're given, so right here it is in 3-2-2, the mean and standard deviation. The sample proportion p hat is normally distributed. So right there, it tells us the sample proportion p hat. That's the sample proportion p hat. The true population mean of the random variable p hat is the mean of p hat equals p.
The mean of P hat
Equals p.
That's where does it say that?
In 3-2-2 in lesson 16.
Okay.
And it says, and the true population standard deviation, and then it gives us that standard deviation formula that we need to use.
Wait, I'm really confused because who's Stacy Stevens?
Sorry, that's me. I just jumped back on it. Cut me off.
Oh, I don't know why that threw me off with your last name.
I was like, what? See, she's named it air, Marley. What are you talking about?
Look at I kept saying Stacy Stevens joined the call. I'm thinking Stevens? Stevens? Who's that? Okay.
Anyway, so the P is the population proportion. What was the question? Oh, the true proportion. And then P hat is the sample proportion.
Okay, perfect. That's what I was wondering.
Yeah, I had to write that down so I don't.
Yeah, I did too. Okay, so number 6. What is N? You know that. It's the sample size. Okay. This is my mom calling. 1 second. You guys, Marlies, we take over for number 7.
Yeah. Yeah. All right. Number 7. If P equals 1/4, 1/4, what is the smallest N that satisfies the requirement? The smallest sample that satisfies the requirement.
So this would be where it's like the N times P
is less than 10. Yes.
Right.
Wait, what is this one like you said?
It's in 3-2-1.
Okay.
NP is greater than or equal to 10, or N times
Okay.
1 minus P is greater than or equal to 10. So we would have to figure out what we're solving for N.
Okay.
P equals that.
Quick.
So it's just 40, right? Is that what you guys are thinking?
Yeah, 40% or point. It tells you right in the next one. Well.
So yeah, just 40. 40.
4-0.
I guess I don't understand that. How come it's 40? Because isn't it 1/4 that would equal 0.40 or 4?
No,
I don't
so
get
1/4 is 0.25, right? 1 divided by 4 is 0.25.
Yeah.
And so you need to plug
Okay.
that in for your P, and then you have to solve for N. So you have 0.25 is greater than or less than 10. So then you'd have to divide by 10 on each side to get it alone. And so it's just solving, and then what do you have left? Then you get N alone, and then you can see that it's 40 or whatever. Does that make sense? So solve for
Yeah.
N in that equation. And
Okay.
0.25 is your P that you're using. Does that make sense?
Yeah, I think
What I
so.
just said.
Wow.
So like on your calculator, 0.25. Okay, good with number 7?
Yeah.
Yeah.
All right. So number 8. So what is the mean of P hat? So this is where I was kind of trying to explain the P hat equals P.
Mhm.
So it equals 0.4.
Okay.
Then what's the standard deviation of P hat? That's the formula we have to use. So if we want to plug all those into our calculator,
It's just 0.4 for 8?
Yeah.
What you said?
Standard deviation of p hat. So if we want to
So
do
that's
that.
the P1 minus P, or the square root of.
Yeah.
P minus Q.
So we know p is 0.4.
Okay.
1 minus 0.4. And they give us the sample size. And then we have to take the square root of all of that.
24. They multiply 0.4 by 1 minus. Right?
So 0.4 and then times 1 minus 0.4 over 24.
Yeah, okay.
And then the square root of that.
Did you guys get 0.1?
So, yes.
Not wrong. Oh, no?
No, that's right.
Oh, good. Thought I did the square root part wrong.
That's right.
So you got what?
0.1.
Okay.
Don't forget to square root it, because at first you get
Right. 0.01.
0.01,
Mhm.
and you square root it and you get 0.1.
Right. Okay.
Alright. Good, Marlies?
Yeah. Yep,
All right,
that's
number
what I
10.
got.
Perfect. So what is p hat for this one? So you think that it would be the 0.3, right? But because we're given more information in this one, it's not the 0.3. It's her hits. So the p hat is the 0.35.
You have to put a
How do you-
decimal in front of it?
Yeah, how do you get that?
So we want to determine the probability that she will get more than 35 hits in the
Mhm.
next 100 bats.
So it's 35
So-
over 100.
So that's her, because yeah, you're at, so that's the p hat equals x over n. So
Okay.
your x is the 35 that she's going to use over 100, so it brings it to 0.35.
Okay. That makes sense.
So when we're given information like that, that's what we have to be careful to not just be like, oh, look, p equals 0.4. Oh, okay, p hat is p4. Because in that equation above, that was the only information we were given. But this is a little bit more detailed. So standard deviation for this, same formula,
Equation.
times 1 minus p. So, and so they give you p. So remember to use your p on that one.
Sorry, you guys. My throat is awful today. So are we just on number 11?
Yes.
Uh-huh.
So you can still use the standard deviation P formula for the P hat and not just the P?
No. Wait, what?
So when
Marnie?
we find the standard, well, on number 11, aren't we supposed to find the standard deviation?
Yeah, of p hat. But,
Right,
but the
so-
formula for that is using p, not p hat. Because we're trying to find p hat.
Okay. Okay.
So did we get 0.046?
Does that make sense?
Yes, it does. Yeah.
Yes. That's what I got.
Oh, I got 0.048. Oh, I must have been a number wrong.
I mean, you get 0.04582, but rounded 0.046.
Yeah.
Man, I don't know what I am typing in wrong.
Are you typing in 3.5 or 0.3?
Oh, maybe that was it. Let's see.
Make sure you're typing in 0.3, not 0.35.
Oh, that's what I was doing wrong. I was putting
Yeah.
in 0.35. Okay.
Don't put in 0.35.
Tricky. Okay. Okay, so it comes out to 0.
0.046.
Yeah.
Yeah.
Got that too.
Okay. All right, so the z-score, and that's the formula where we use p hat minus p. So we do know p hat minus p, and then over the standard deviation formula.
Oh, sorry to stop you guys real quick. Did anyone else get something that said field must be a valid number when they put in 0.046? Or is that just me?
No.
Huh, no.
Ugh.
Oh, now it went away. I don't know.
Okay,
Good. Sorry.
no, that's okay.
So
No.
for the z-score, we just do the 0.35 minus 0.3 over 0.046.
Yes.
0.35 minus 0.3 divided by the sample size, which is still 100, right?
No, isn't it divided by the standard
Wait,
deviation?
what,
Or
Marlies? No. This is the z formula, so it's p hat minus p
Yeah.
over the standard deviation formula.
Oh, the standard deviation. Yeah, I have that. For some reason, I was thinking.
Oh,
Yeah, I just said the whole thing.
well, I mean, we already
did that. Yeah.
we already figured out that the standard deviation was 0.046.
Yes. Okay.
So really all we have to do is do the p hat minus p over 0.046.
Right.
And then what'd you get, Cheyenne?
1.09.
So I got 1.08695
Yeah.
whatever. So 1.087. 1.087.
Yeah.
That's what I got.
okay. So, what are you guys rounding it to?
1.087.
I rounded too soon. That was
Okay.
3 decimals.
Yeah.
So then now we need the probability applet for number 13. And we need to put in our z-score of 1.087. And it's asking that she'll at least get that many hits. So we need to do everything. Well, we just need to do greater than the z-score, not the middle.
not the middle.
So if we do that,
Because it said what? What was the wording there?
at least
At least.
35.
Okay.
And so in the applet, we get an area of 0.1385.
0.1385. Yeah.
Yeah, so rounded is 0.139. Bring it to me. Right here? Is it up here? Oh, is it up here? Yeah, bring it to me. All right. So that was 13. Okay, 14. So what is the standard deviation of p hat? So that's the formula. I'm sorry, baby.
Did you guys get 0.01117?
Yeah.
Okay, so for this one, you guys are using the standard deviation formula, right?
Yes.
Yeah.
But we're looking for the standard deviation of p hat. So is this, in this case, we're just looking at p, the value of p is the value of p hat?
Say that one more time.
Well, so for question 14, we need the standard deviation for p hat, right?
Right.
Right. Which is
So-
just the formula.
Yeah, but so does that mean the standard deviation for p hat is the same as for p?
What one are you guys
I
on?
don't know.
14.
Okay.
So we're supposed to find the standard deviation of p hat, and we have the
Okay.
standard deviation formula. And I was just asking if that means the same standard deviation is the p hat standard deviation the same as p?
No.
Standard deviation for p, I mean.
No. So you're using P in that formula, 0.52,
Okay.
in order to find the standard deviation. Did you do all that?
Okay, yeah, the standard deviation formula, that, I guess what I don't get is that gives us the
That-
standard deviation for the p hat automatically?
Yes. When you do it.
But it doesn't say standard deviation for p hat.
The formula says
In the textbook, it did
the
say.
formula for P hat to find this to find the standard deviation for P hat
Yeah.
is the square root of P
Yeah.
times 1 minus P over N.
Okay, I'm sorry. I guess I just must have written that down wrong in my notes. But thanks for clarifying that.
Yeah.
Yeah.
It's in 3-2-2, the where it says that.
No more milk.
So then we would just use the z-score of p hat.
Sorry, so did you guys get number 14.011?
Yeah.
Oh, okay. And then the Z score, so you're on number 15.
Yes.
Okay.
So
Great.
Oh, I
so
think I got-
what is p hat then? It's just equal to p for this one.
That's
No,
see, that's why I was
No.
confused.
What's p hat?
P hat is 0.011.
So for the z-score, would you do the p hat subtract the p over
No.
standard deviation?
I thought 0.011 was the standard deviation, not
Of P.
hat
But
itself.
oh, is that what you're asking, Marlies? So is the
Yeah,
standard deviation of P hat automatically P hat?
Yes, that's what I was asking.
Oh, sorry. Yeah. Yeah.
Okay.
Sorry.
So is that
So
that
yeah,
what we use?
P hat,
Or-
yes, that is what you use.
Okay, so it's not actually the standard. Okay, the symbols are confusing me. Okay.
Oh, well, no. Shh. Wait, let me remember
so
on
do we use
this one.
do we use
No,
like
sorry,
sigma
sorry.
or p hat?
No. I'm sorry. I messed you guys up. No. What I said was completely wrong. You're right. It is standard deviation. The key to this question is your P hat that you're going to be using is 0.50, I believe, because they
Because
have to
that's
get
the
less than
sample size.
50%.
50.
Yes. Sorry. So redo that and do 0.50 because you have to use the standard deviation of P for
Okay.
this. Then minus 0.52 equals a negative that then divided by
0.011. Okay.
0.011 equals, sorry, that one I forgot. That one took me a minute to realize what P was. I mean, what P hat was.
So then our Z score is 1.818.
Negative.
Negative. Right.
Yeah. Sorry. So does that, sorry, Marlies. No, it does not mean that is not P hat. Sorry to confuse you.
I am still confused.
Okay.
But if I were to use the Z score formula, couldn't I fill in P hat with the P hat formula, which would be the X divided by the N?
Let me. Well, you'd have to know.
What I
Individual
thought is,
sample size.
like, I would have never thought to use that 50%, 0.50 as the P hat.
Well,
Right.
if you do, yes, Marley, because if you do the X over N, it would be, you're looking for 50%, so you would put 1,000 over 2,000,
Yeah.
and it would give you 0.5,
0.5.
which is 50%. So yes, I think
Okay.
I think you're correct in that.
Okay. That threw me for a second. Okay.
Yeah.
Makes sense.
Yeah.
Yes, it took me a while to realize that you use 0.5 as well for the Stacy.
Okay.
Because I kept using the standard deviation. And I was like, wait, you're not supposed to do that. So what is the P hat? But like Cheyenne, you could still figure out the P hat by using the formula of doing the.
What formula did you say, Cheyenne, that you could do? Sorry.
Let me
P
go.
hat is P hat equals X divided by N.
Yep.
Okay.
That's at the very top of the lesson,
Yeah.
like 2-1-1.
Right.
So your X is the number of individuals in the sample with that characteristic.
Okay.
So if the sample size is 2,000, we know we have to get the 1,000 to be the characteristic sample size. So if you divide that, then you get 0.5, which is 50% of the votes or whatever.
Right. Okay.
So yeah, that was the Z-score for that. And then if you want to type in the Z-score into the probability applet,
So then I'm still a little confused on how we know which sides to shade, because it's a little different wording than
normal.
normal. Yeah.
So this one says it will suggest in losing the election. So they have to get less than 50%. So we're only going to shade just the left side.
That's just like in Unit 1, where we kind of pay attention to the less than, greater than, right?
Yeah.
For Unit 1.
Except-
Yeah,
Except the greater than in this case that we used, we only did greater than, not the middle.
Right.
But remember, that's because we didn't have a negative Z-score to start out with.
Right.
So we get
Yeah.
0.035.
Yeah.
That's what I got.
Okay. Well, Larky, I'm glad you knew what you were doing here.
You all knew what you were doing too. It's just plugging in the numbers. So I don't know if I don't think we have to broadcast us talking about our group project, right?
No, we just have to turn in there's a Word document, right?
Yeah,
Right.
so I have that Word document pulled up. So I'm going to stop the broadcast,
Okay.
and then we'll continue on with our design the study project. Let me stop that.